The dawn of quantum computing, Willow and the collision with parallel realities. In December 2024, Google unveiled its most advanced quantum chip yet, Willow. Heralded as a game-changer in the world of quantum computing, Willow isn't just fast, it's staggeringly powerful. This 105-qubit superconducting processor has the potential to redefine our understanding of computation, making it faster, more efficient, and capable of solving problems that were once deemed unsolvable. However, Willow has done more than just break records. It has uncovered something far darker and more profound than anyone could have imagined, a potential collision with parallel universes. Ryan Montgomery, an ethical hacker with a reputation for uncovering sensitive information, recently revealed a chilling discovery. Willow's quantum calculations didn't just solve complex problems, they revealed evidence of alternate realities. What seemed like a groundbreaking scientific achievement is now being viewed as something far more dangerous, a gateway to parallel universes. Could this be the greatest breakthrough in the history of technology, or is it humanity's first step toward its most profound existential crisis? As we venture further into the unknown, we must confront a chilling possibility. In our quest to unlock the mysteries of the universe, we may have inadvertently opened a door to another one. Quantum computing, a glimpse into the future. To understand the significance of Willow's discovery, we first need to dive into the world of quantum computing, a field that promises to revolutionize everything from medicine to artificial intelligence to climate science. Unlike traditional computers, which process data in binary, with bits that represent either a 0 or a 1, quantum computers use qubits. Qubits are a unique kind of data unit because, through the phenomenon of superposition, they can exist in multiple states at once. This property enables quantum computers to perform many calculations simultaneously, making them incredibly powerful and capable of solving problems at speeds far beyond the reach of classical machines. Another essential feature of quantum computers is entanglement, a quantum phenomenon in which the state of one qubit is inherently linked to another, regardless of the distance between them. This connection allows quantum systems to process information in ways classical computers cannot, enabling quantum machines to solve incredibly complex problems in mere moments. As revolutionary as quantum computing is, it comes with its own set of challenges. Qubits are highly sensitive to their environment, which can lead to errors in computation. To make quantum computers reliable, researchers have been working tirelessly to develop quantum error correction techniques, an ongoing challenge that the Willow chip has begun to address in truly remarkable ways. The promise and potential of quantum computing. The potential applications of quantum computing are virtually limitless, offering solutions to problems that were once thought insurmountable. In medicine, quantum computing promises to accelerate drug discovery by simulating molecular interactions with a level of detail and precision previously unimaginable. Diseases such as cancer, Alzheimer's, and even rare genetic disorders could see rapid breakthroughs, dramatically improving the lives of millions. In artificial intelligence, quantum computing could significantly boost the processing power of AI algorithms, making them faster, smarter, and more capable of tackling real-world challenges. AI-driven advancements could transform industries such as finance, logistics, and cybersecurity. With quantum computing, the possibilities are endless. Quantum computing could also revolutionize materials science by enabling the creation of new materials with properties that were once thought impossible to model or even conceive of. This could lead to innovations in everything from energy storage to advanced construction materials to new technologies we haven't even dreamed up yet. Google's quantum leap, Sycamore to Willow. Google's work in quantum computing has been nothing short of groundbreaking. In 2019, the company introduced Sycamore, a 53-qubit superconducting processor that made headlines for achieving quantum supremacy, the point at which quantum computers surpass classical ones in specific tasks. Sycamore performed a complex calculation in just 200 seconds, a task that would take the world's most powerful supercomputers approximately 10,000 years to complete. Though there was some debate over the results, Sycamore's achievement marked a key milestone in the development of quantum computing. It demonstrated that quantum computers were no longer a theoretical concept, they were here, and they were powerful. Fast forward to 2024, and Sycamore has been eclipsed by Willow, the latest and most advanced quantum chip in Google's arsenal. With 105 qubits, Willow represents a major leap forward in quantum computing capabilities. In tests, Willow has solved problems that would take classical supercomputers billions of years to compute, in mere minutes. The chip has shown an unprecedented ability to tackle some of the most challenging issues in quantum computing, such as quantum error correction. By reducing error rates to below the threshold needed for effective error correction, Willow has made large-scale quantum computing a practical reality, and the implications of this achievement are profound. The unsettling discoveries of Willow's design is built to maximize qubit coherence times and interconnectivity. This enhanced architecture allows qubits to interact more efficiently, enabling Willow to perform calculations that would otherwise be impossible for classical systems. For example, Willow completed a benchmarking test in under 5 minutes that would take classical supercomputers an unimaginable 10 septillion years to complete. This kind of performance is not just impressive, it's revolutionary. However, Willow's true significance goes beyond its raw computational power. As researchers dug deeper into the chip's capabilities, they stumbled upon an unexpected discovery, the possibility of parallel universes. The quantum computations performed by Willow seemed to tap into an entirely new dimension of reality, hinting at the existence of other universes. These findings suggest that quantum computing may not just change the way we solve problems, it may change our very understanding of existence itself. Could quantum computing, with its powerful ability to manipulate the building blocks of reality, be the key to unlocking parallel dimensions? Or are we venturing too far into unknown and dangerous territory, risking a collapse of the fabric of our own universe in the process? Willow has become a symbol of both possibility and peril, a glimpse into a future where the boundaries of space, time, and reality itself are no longer fixed. The ethics of quantum discovery. As quantum computing progresses, ethical questions about its impact on humanity and the universe become increasingly urgent. The discovery of parallel universes, coupled with the risks of unintended dimensional collisions, has sparked heated debates among scientists, ethicists, and governments alike. Could the powerful capabilities of quantum computers be used to manipulate the very fabric of reality? Should this technology be pursued without limits, or do we need to establish safeguards before venturing too far into the unknown? While some researchers view these new discoveries as an exciting frontier, others argue that the potential dangers far outweigh the benefits. As Willow continues to push the boundaries of what's possible,